Alright, so in the previous class, I have shown you the implementation of logistic regression, and here we have to import logistic regression from linear model. The reason I have already mentioned, it's a classification algorithm. So we also took the problems related to classification. Okay, Iris data set I took, which is present in sklearn. It's having three classes for the flower, and the features are the length and the width: sepal length, sepal width, petal length, petal width, and target were mentioned like 0, 1, and 2. Okay, that is the types of iris flower. Okay, very small data set. We trained our model. Max iteration 200. That means if you recheck the entire derivation of logistic regression and how we found the optimization del L by del beta naught, del L by del beta 1. So we have to optimize the parameters. For that, this algorithm is iterating 200 times. And I have also written you the optimization equation. Okay. So our model got trained, we performed the prediction, then we printed the accuracy, confusion matrix, classification report, everything we have printed. I need to discuss about this today. What they are in detail, I need to talk because they are the evaluation criteria for the model, classification model. Okay, so this is your confusion matrix. Fine. And the rest are the classification report values printed. The accuracy is coming 100% because it's been expected by the logistic regression model to have a good data set. That means the entries should be more. However, our data set don't have that much entry. It's just for demonstration purpose. Now we are doing this code. Okay. Then I have made decision boundary also. Okay. And in the decision boundary, we proceeded for the code similarly. We trained over Iris dataset only. Okay. And the X and the Y. Okay. Here you can check. The X is, it means all the rows. And this means only the first two columns. Only first two columns. Colon 2. So this is for row, this is for column. So if I'm writing column, okay, so that means all the entries present in the row are considered. Colon 2 means, okay, starting from 0th column till second column. Second is excluded. So we'll be taking 0th column and 1th column. Okay, target is as usual. We perform training, testing, everything we done. Okay, and here we are making the range for the decision boundary. That means from where to where it will start. And then here XX, YY, these are the two parameters which you are assigning to mesh grid. That means whatever be the minimum and the max values you have taken, you are going to create a grid of it. Okay, and then this is the prediction Z. Revel means you are going to flat. Okay, that means convert the things into 1D. So flattening X values and the Y values, and then performing the reshape. Then finally plotting. So in this particular code, there are few things which you should know. in context to numpy. Okay, here we are using numpy as a library, so you should know how to prepare a mesh grid. Then there are certain more functions like reshape, how to reshape an array, numpy array. So all these things are present in numpy, and I am available with the tutorials, so I can share this with you, so you can practice. Okay, very basic functions, not a big deal. Here we have made the decision boundary plot. First, we are plotting the contour x x y y z contour. Okay, we are having x x y y. That means it represents the limits, and then z is the value prediction. And within these limits, we need to draw these values. Okay, prediction. Fine. This is the scatter plot by taking x train 0 and x train 1. That means all the values of feature 1 and feature 2. Here we are taking all the values of feature 1 and feature 2 of testing data. So this is for training data. This is for testing data. Okay. And C is equal to y train and the y test. That means the values outcomes of your training and the testing. So y train and the y test. We are marking them with O and S. So this is your training and the testing data points. Okay. And then rest is X label, Y label, and all these things. There doesn't make any sense. Only the thing is here you are making the contour with red, green, and the blue. Okay, so these are the limits. This is the prediction of your X, X, and Y, Y, which you have taken here. So according to this prediction, I guess these boundaries will be created. Okay, here you can see. And we are having training and the testing data. Okay, this is your purple training, and green one is testing data. So purple and these squares are the test data. Okay, we do have the colors like red, green, and the blue. So they are related to XX, YY, and ZZ. Okay, so red, green, and blue. These represents the contour regions. Red, green, and blue. You can see this is red. The entire is red. This is green, and this is blue. And then training and the testing data points are present in form of scatter plots. Okay, so we have made the contour region by these three. XX and YY we have calculated from here by mesh grid by taking the limits of X min max, Y min max, and then Z we have performed the prediction over XX and YY. Okay, accordingly we have made these three regions, and we are putting the training and the testing values here on the contour. So whatever be the points you are getting now, so it will be clear. That means these points are present in red region, these points are present in blue region, these points are present in green region. This is how, see, points, they will be like as it is now. We are having sepal width and the sepal length. So point will be plotted just by this particular function scatter plot. What new you have done is you have made this grid, mesh grid, where you are preparing the things like here contour. Okay, so scatter plot will remain as these points like only, but region you are creating with the help of contour. Okay, so this is how I made a decision boundary. I did further more codes. They are similar. Like I can change the data set. Now I'm taking a wine data set for classification. That is also present in your sklearn data sets. So all I'm taking now from the reference data set only. Iris, wine data set. breast cancer data set. They all are the reference data set which are present in the sklearn. Okay, so here also I'm taking only the two features. Target I'm having, train test split, I trained my model, model can perform the prediction, accuracy I have printed, and then same I made the decision boundary, same I made the contour, same, everything is same, everything is same. You can see here also in one data set we are having three decision boundaries, three classes. Okay, three classes are there. Accuracy is coming like 78% with logistic regression. Okay, we'll be talking more on it, like these parameters. Then I took breast cancer data. Okay, again I am taking the two features: target, train test split, logistic regression training, model prediction, accuracy. Okay, same. Here I am having 91% accuracy. Okay, why I'm taking only two features? The reason is, okay, let's because consider only two feature for making a decision boundary, and it's a binary classification problem. You can see two regions are present, so it's a binary classification because either someone is having a breast cancer or not, zero or one. So it's a binary classification. So two regions are built, two decision bound. matlab, One, there's a one boundary, there is one boundary, and two regions are built. Okay, so it's a binary classification. The entire code is all same, just only I changed the data. That's it. Okay, fine. So this is your breast cancer data set. Okay, and then if we need to perform digit classification, okay, so I am having low digits data for the classification. All right, and here it is. So just use the first two features and the first two classes, that is the digits. Again, I'm using the two features only, and digit classification I'm using first two digits, 0 and 1. So classification also I'm converting it to into the binary, and features also I'm taking only two. Okay. Then again I perform train test split, training of the model, prediction, and everything is also. And this is 51% accuracy, very low accuracy. My model struggled to find the patterns in the data according to the logistic regression model. Okay, so let me share my entire screen. What I have told you so far, we will be having a bit discussion over it. Okay, so we were training logistic regression model. Okay, so logistic regression model training you are doing. Now it's quite clear from the codes that you can import logistic regression from linear model. You are available with the data. We have worked on certain data like iris data was the first one. Then I took wine data set also. I took breast cancer data also, and then your digit classification also. Fine. Iris is having three classes. Wine also having three classes. Breast cancer is having two classes. Digits I am having 0 to 9. That means 10 digits. However, in the code, I took only two. Okay. And then what I did is, after training my model with the data, I took two features only for the training. For example, in case of Iris dataset, you are having one, two, three, four features. One, two, three, four. And this is your target. You are having sepal length, sepal width, petal length, petal width. All are numerical features. And then you are having target, setosa, versicolor, virginica. Three classes are there. So you took only two, and you have trained your model with only these two, keeping the target as y. Okay, the reason is like might be we are not in consideration that taking all the feature, because it may lead to overfitting also. We may have dependent features, so it's better just take two features initially. Just take these two features only. Okay, and train your model, because I need to make decision boundary also by considering two features. That's what I did. Sepal length, sepal width. Okay, these two features I took, and then I made what, scatter plot also. So sepal length, sepal width, I made a scatter plot, x train, x test, y train, y test. So there will be these dots present between sepal length and sepal width. Okay, the point is entire plotting is been done on behalf of contour. Okay, like contours are something. If you can see, these are such kind of plotting contour which show the depth. This is called as contour. Okay, these regions, it shows the depth. So it's a contour. So similarly, I took first, I found the limits of x and y. Then I calculated x and y by mesh grid. Okay, so mesh grid is something like this. This is mesh. Okay, this is mesh grid. When, like a graph paper. So this is mesh grid. Then I perform the prediction Z, and then I considered x, y, and z all to make the decision boundary. That's what I did in every code. Now for the evaluation of the model, you are seeing few things. Every step is cleared like in this way. You can import the library, you can take the data, you can perform pre-processing of the data, you can perform train test split, you can give data to the model, you can, after training, perform the prediction. All these things, all these steps can be performed by you. At the end, you have to evaluate your model. Okay, evaluate your model. We did the same in linear regression also. For evaluation there, we calculated MSE, MAE, RMSE, R2 score, adjusted R2 score. All these were the criteria to evaluate a model, linear model. But in case of logistic regression, since it's a classification algorithm, so we have to better use different metrics, evaluation model. That means different metrics we are going to use it to evaluate the model. Okay. The point is, if we check this thing, MSC, mean square error, we haven't used this formula. Okay, mean square error, na? Fine. Mean square error is y dash minus y का summation, this का whole square divided by n. Okay. So if I take MSE and let me make y dash and y. So y dash is predicted. Let us suppose we are doing binary classification. So if y dash is 0, y is also 0, y dash is 1, y is 1, y dash is 0, this is 1, this is 1, this is 0. So if we perform this MSC over it, 0 minus 0, 0 minus 0 का square तो 0 plus 1 minus 1 का means 0 का square is 0 plus 0 minus 1 cos square is 1, and okay, so divided by n, okay, I will be taking ahead 1, and next one is also 1. There are 4. Okay, so 1 plus 1, okay, by 4, that mean be like 2 by 4, zero point 0.5. Zero point 0.5 mean square error is zero point 0.5, but mean square error do have a kind of interpretation. Mean square says that we have to use it when the data points are away from a line, how much they are far away from the line. Such kind of error is MSC. However, in case of classification, you are not performing this thing that how much far away you are from the line. No, you are calculating error in case of classification, yes, but that is like y log, okay, y log p minus 1 minus y log of 1 minus p. This is your cross entropy. This is the error which you are calculating for classification. Okay, cross entropy. And if you are having two classes, so binary cross entropy. So you have to apply this thing for calculation of error. Okay, so it's y is actual and p is obviously predicted. And I hope you remember I taught these two by taking example of apple and peach. Okay, that's a basic example that helps a lot in understanding cross entropy. So such kind of errors needs to be calculated, not the error which you perform in linear regression, that is not followed in logistic regression. So these terms will be discarded. MSC discarded, MAE discarded, RMSC discarded. Now the question is, sir, R2, whether we can perform R2 in logistic regression. Okay, if you are not considering error like what we did in MSC, error we are considering this one. Okay, this one we are considering for error calculation, for classification. Okay, not MSC. What about R2, sir? R2 is about variance, no, sir. R2 is about variance. It's been said, sir, variance explained. That is R2. Okay, so what kind of variance explanation we are expecting in classification? What we are expecting in the classification? Yes, variance explained in classification. We mean, like, as we have seen in linear regression also, that if you are having x1, x2, x3, x4, these are the features, this is your target. How much these features are contributing in prediction of y? This is R2, contribution. Okay, we are having features. We are putting this feature into the equation, linear model. And R2 means that only contribution of these features, because we are taking these features, we are training our model on the behalf of these features. So at least it's our right to know whether the features which we have taken, are they literally helping us in finding the target or not. Okay, that is hard to. whether this thing is applicable in logistic also. Logistic is also been like these features are there and target is there. So how much these features are helping in predicting the target, that is the classification, that is 0 and 1. Okay, the equation says we have already used, we have to, in our log of odds. Okay, so what the log of odd means? Log of what is odds? P upon 1 minus P. That is log of odds. Okay, and value of P is 1 upon 1 plus e की power minus y. And that will be 1 upon 1 plus e की power minus beta naught plus beta 1x plus beta 2x dash plus beta 3x double dash. If you are having four features, so I can write it like this. Beta naught, I can write it like this. Your value of P will be 1 upon 1 plus e की power minus beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. So obviously, how much, okay, features are present now here. So how much these features are contributing to get me a probability value. So here contribution of features is expected. So I guess R2 cannot be discarded in logistic regression. MSC, MAE, RMSC, that we have discarded because the phenomena, the concept they use is how much far away a point is from a line. But in case of logistic regression, we are not saying that. In logistic regression, we do have a threshold. This is the phenomena for logistic regression. Threshold. You know, the logistic regression is having sigmoid function and it takes a value between 0 to 1. Zero point 0.5 is the threshold. Anything above the zero point 0.5 is class 1. Anything below the zero point 0.5 is class 0. So we will be having the values present here. Okay, either here or either here. Okay, either the value of y is 1 or 0. Okay, you can take any of the feature at the moment. Okay, here you can take the features and your target will be like 0 and 1. So we are having threshold here, not the line and the distance of a point from a line. Okay, so those errors are rejected. However, R2 score, R2 score, I think we have an idea what it means can be used. Okay. However, in classification algorithm, still the metric used, as we have seen in the codes also, in general, are accuracy, classification, report. Okay, and we do make confusion metrics. Okay, confusion metrics. That's what we use. For confusion metrics, we should be knowing these terms: true positive, true negative, false positive, false negative. These terms should be known. Then only I can make a confusion matrix. Along with that, I do have some more terms like precision, recall, F1 score. That's what you are seeing. We are having, okay, accuracy. Accuracy can be like this: true positive upon TP plus TN plus FP plus FN. Okay. So accuracy means na like total number of instances, total number of instances, that means the values. I can take TP plus FP, total number of correct. Okay, total number of, that means total instances in the denominator, and in the numerator it should be like correct, correct predictions. So correct predictions are TP and FP, and this is all, all the predictions. So correct prediction divided by all prediction, that is called as accuracy. Okay, got it. Fine. So it's not like that, sir. Do you have to check somewhere that how accuracy is calculated? We have to think over what could be a formula? No. Accuracy is quite like, it's a clear concept. Out of total, this much are the correct. Okay, in general context also we can say, for example, we are having 100 entries. 90 entries are correct. What is the accuracy? 90%. The point is clear. We do not have to think too much. Okay, now the thing is, sir, you have written TP, TN, FP, FN. What this are? All right, all right. Let's have again discussion on it. P means positive, N means negative. The question is, sir, whom you are calling positive and negative? And it is mandatory to write positive and negative, sir. Whom you are calling positive and negative? And since you are working with a classification problem, in classification, there are only two possibilities. Either the model correctly classify, or either model incorrect classify. Incorrect. In classification. Correct and incorrect classification. There are two possibilities in classification. For a correct classification will be something like that. For example, binary, you are having outcomes. So for correct classification means 0 ka 0, 1 ka 1. That means if actual is 0, predicted is also 0, actual is 1, predicted is 1, correct classification done by the model. Incorrect means 0 ka 1, 1 ka 0. That means actual y is 0, y prediction is 1, y is 1, prediction is 0. So here is the confusion. Here is confusion. Model is unable to understand according to the data points what could be an answer. So this is the confusion part. Okay, so what is suggested? You can do one thing. Let us suppose 0 means positive, 1 means negative. It's just our assumption. Okay, 0 means positive, 1 means negative. Our assumption. And I have told classification can be like correct and it can be like incorrect. So you can see here one, two, three, four. Four types of possibilities for binary classification. Okay. So in order to draw this outcome, we can make a matrix. Okay, like this. Right now we are talking about binary classification only. We are having 0 and 1 as outcomes. Here also write the same thing, 0 and 1. This is actual, this is predicted. So 0 and 1, these are actual values of the model, not the model, actual value present in the data. This is what model predicted, 0 and 1. Okay. Now, 0 is positive, 1 is negative. You have assumed this thing, positive and negative. So if the actual value is 0, model also predicted 0. This is true positive. Positive you have already considered. 0 is positive. That you have already put in your assumption. And if the actual and the predicted both are same, both are positive positive, then true positive. Okay. This is one negative. This is also one negative. So if the actual is 1, model prediction is also 1, it is it is true negative. Okay, it is true negative. Negative is just 1. True means okay. Model prediction and the actual value existence is also the same. So it is true negative. Now, if actual is 1, model predicted it as 0. This entry. Actual is 1, model predicted it as 0. That is false positive. Why? Because this is positive, na? But model falsely by mistake because of confusion, instead of 1, it predict it as 0. That is why it is false positive. Again, same thing here. Actual is 0. Model predicted it as 1. It is false negative. Got it? This is called as confusion matrix. I hope I am good enough here to explain you confusion matrix. Did you understood the confusion matrix or not? Though it is a confusion matrix for model, but we as a machine learning engineer get confused how to make this entries, where they are present, and what is TP, what is all these things. Now we confuse, but actually it's a confusion matrix for model. Okay, it's a very easy case. For example, if you are having multi classification, you are having 0, 1, and 2. Let us suppose three classes are there. So, what you will do in this particular case, don't worry at all. No need to worry. Just follow the same concept which I have told. Three entries are there now. 1, 2, 3. 1, 2 and 3, 0, 1 and 2, 0, 1 and 2. This is actual, this is predicted. Okay, now it is not mandatory that you will Always say 0 positive, 1 negative, 2 what you are going to give 2 here. Okay, neutral. It is not mandatory. You can work like in this way also. Not mandatory. You can work like this. Actual is 0, predicted 0, true 0. Okay, actual is 0, predicted 0, true 0. Actual is 1, predicted 0. So this is false 0. But false 0 in context to 1. Now, now, as I told, it's not mandatory. Okay, it's not mandatory. However, if you want for your simple understanding, you can use it here. But meaning will remain the same, and you have to understand. For this is false 0 in context to 1. This will be also false 0, but in context to 2. That means in this particular case, model wrongly predicted 1 as 0. Here model wrongly predicted 2 as 0. Okay, so for 1 also model is saying 0. For 2 also model is saying 0. Understand? Now, this is 0, predicted is 1, false 1. This is 1, prediction is also 1, true 1. This is 2, 1, false 1. But remember, this false 1 and this false 1 have a different context. Just like as I explained here. Different context. Okay, now actual is 0, predicted is true, false 2. This is also false 2, this is true 2. So on the diagonal, you are having the true values. True values are present on the diagonal. Rest all you are having false values. Rest false values. Okay, that means wrong interpretation by the model. Model got confused here. For some values, model confused. Instead of 1, it gave 0. Instead of 2, also it gave 0. Okay, so model confused in differentiating 0, 1, and 2. And it gave answer as 0 only. Okay, somewhere model confused in these three and gave answer as 1. Somewhere model confused again in these three and gave the answer as 2. So what are the number of entries for those are available here in these cells? You can have a confusion matrix like this. Okay, like this. 100, 10, 20, 200. So model correctly predicted 0 as 0 with 100. 10 times the model got confused and it predicted 1 as 0. 1 as 0, yes, for 10. So if I say 0, 1, 0, 1, so 100 times model is correct for this. One time for 1, 10 entries model gave it as 0. Instead of 1, model gave 0 as an answer. Here For 0, model gave 1 20 times. For 0, model gave 1 20 times. Huh. For 1, 1, 200 times model got correct. Okay. This is how you can prepare. So total number of values which we have given model for the prediction are 100 plus 10 plus 20 plus 200, that is 330. These are the total number of values. Okay. And how many out of this total? 330. So total number of instances are 330. How many are the correct instances? 100 plus 200, 300. So 30 upon 33 into 100, that will be the accuracy of the model. Got it. Fine. This is how you can calculate accuracy. Okay, fine. I hope you understood today's lecture, isn't it? Did you find interesting or not today's lecture? Let me stop presenting. Let me stop recording also.